Welcome back to P3. Today we're looking at Unit 3.4, Trigonometric Identities. Now, starting with my base sine squared x plus cos squared x equals 1, I can create two additional identities. So, sine squared x plus cos squared x equals 1. Now if I divide through by sine squared x, then I get 1 plus cot squared x equals cosec squared x. And this is then my second identity. And again, if I start from my original sine squared plus cos squared equals 1, and this time divide through by cos squared then I get sine squared over cos squared is tan squared x plus 1 for cos squared over cos squared, and then sec squared x for 1 over cos squared. That gives me my third identity there. So now we've got these three identities to use. Now you can go ahead and memorize these two, okay, or you can just remember how you created them. So you can always just simply start from sine squared plus cos squared equals 1, and you can create this straight in your head and write it down. There's no difficulty there. Now let's use these. So with this proof, left hand side, so cosec squared x minus sine squared x. Now cosec squared x is 1 plus cot squared, and sine squared I'll be able to turn into cos squared, so that's my aim here. So this is 1 plus cot squared x minus, and then sine squared will be 1 minus cos squared x. So 1 plus cot squared x minus 1 plus cot squared x. So that equals cot squared x plus cos squared x, which is my right hand side. So nice and easy with the proof there, same setup as previously. Okay, now with this one, what I would do is start off by thinking of a simple right angle triangle. Okay, if this is theta, cos theta is adjacent over hypotenuse. And I need to find my missing angle. If you recognize this Pythagorean triplet, you'll know that as 7. If not, you would want to do 25 squared minus 24 squared and then square root. Okay, so from this I want to find out what cot theta is. So cot is 1 over tan, so we start there. Tan theta is opposite over adjacent, so 7 over 24. That would mean that cot theta is 24 over 7. Now that's okay so far, but one bit that we haven't addressed yet is that theta is a reflex angle. So for this one, what I would do is just think back to, our cast rule method. So reflex means that I'm looking between 180 and 360 degrees. So I'm looking in this section here, and what I've got here, we've got that cos theta is 24 over 5. So if I look up here, I can see that cos theta is positive. So if I'm looking in these two sections, there's only one section where cos would be positive, and that's this section. So I can immediately say this is the section I want. And in this section, tan is negative, therefore cot is negative. So finally my cot theta is minus 24/7. And that would be my final answer there. Okay, when I'm solving an equation that looks like this, you can see the squared term, non-squared term. So we're looking at a quadratic style equation. When I have it in this form, what I need to do is change the squared term to match the non-squared term. So in this case, I know that tan squared can be replaced by sec squared theta minus 1. Now I want to expand my brackets. And I'm going to take the 4, get everything onto one side. So 3 sec squared theta plus 4 sec theta plus 1 equals 0. Now I need to factorize. Sometimes you might need to use the formula for this. But not always. And we've got a 1 and a 1. 3 sec squared, 3 sec plus 1 sec, 4 sec, and that's 1. So there we have it. So 3 sec theta plus 1 equals 0, and sec theta plus 1 equals 0. So sec theta equals minus 1/3, sec theta equals minus 1. This would mean that this is 1 over cos theta, which is minus 1/3. So cos theta equals minus 3. This is impossible. And then we've got 1 over cos theta equals minus 1, and cos theta will equal minus 1. Okay, this one obviously I can solve, and it will be 180 degrees, and that will be the only solution to this problem. Okay, so just need to be careful there. Alternatively, when you did get to the kind of factorizing stage, you could say let y equals sec theta, and then you get 3y squared plus 4y plus 1 equals 0. And you can think of it that way then to factorize, or, you know, complete the square if you want, or use the formula, whatever you prefer. So if cot theta equals minus 1/3, then tan theta will equal minus 1 over 1/3. Okay, so it's worth getting to that point straight away. Then if I also have a little look at my cast diagram, okay, between 90 and 180 puts me in this section here. Okay, in this section. Now, that's important when I start to look forward. Now, what I want to do is find out a value of theta, or not necessarily theta, but certainly what it might be. Tan theta is 1 over root 3, and then if I square the 3 and square the 1 and square the square root, you know, I know that this value here is 2. Okay, it's quite a common one. Now you'll notice I'm not using that negative sign, this negative sign here. Okay, it's not important for this step because it's negative, because tan is negative in this section. Okay, sine is positive, cos is negative. So if I look at it, sine theta is equal to opposite over hypotenuse, so 1 over 2, and it's in this section, so it's positive. Cos theta is adjacent over hypotenuse, so root 3 over 2, root 3 over 2, and again it's in this section cos is negative. Okay, part A, let's look from the left hand side. Sec 4 theta minus tan 4 theta. So looking at this, we are looking at difference of two squares. So this will be sec squared theta plus tan squared theta multiplied by sec squared theta minus tan squared theta. Now, this first bracket is exactly what I want. So looking in the second bracket, sec squared is tan squared theta plus 1. And then we still have that negative tan squared theta. So these are going to simplify with each other. Just leave me 1 in that bracket. So we get sec squared theta plus tan squared theta, which equals my right hand side. Okay, part B. This time I'm going to go from the right hand side. So we got sec squared theta minus 1 minus sine squared theta. We want cos squared theta. This is a 1 over cos squared theta, so I'm not going to touch this. But this I can replace. 1 minus sine squared theta is cos squared theta. So we get sec squared theta minus 1 multiplied by cos squared theta. So cos squared theta sec squared theta minus cos squared theta. Now you'll notice that the cos squared and the sec squared will cancel out, but I will do the extra step for you there. Apologies there, I wrote cosec on the bottom again. Cos squared theta. So these will cancel, leave me with 1 minus cos squared theta, so equals the left hand side. So that one, there was a bit more information on the right, which made it easier to start with than the left. And part C, again, I think I'm going to start on the right hand side. Looks like we'll have some fractions, so let's jump straight in. 1 over sine theta, tan is sine theta over cos theta, and that's times by 1 over cos theta. So I want to put these as a single fraction, so I'm going to put them over sine theta cos squared theta. So it'll be cos squared theta plus sine squared theta over sine theta cos squared theta. Okay, so that's what I do when I'm separating out, but I'm just going to do it, normally I would do this in one go. So normally, just to show you, but I would just jump in as a single fraction. I know this has to be over sine theta cos squared theta. So cos squared theta plus sine squared theta. And you can double check, cos squared over this would give me 1 over sine theta, and sine squared over this, one of the sines will cancel, giving me sine over cos squared theta, so it is the same. At the top, cos squared plus sine squared is 1. And there we have 1 over sine theta is cosec theta, and 1 over cos squared theta is sec squared theta. So there we have it, equal to the left hand side. I do normally just prefer to keep going down in one line, but just for room, I've gone there. Okay, part A, sec squared theta equals 3 tan theta. I always want to change the term that is squared, and I want to have it match up with the term that is not squared. So in this case, sec squared is equal to 1 plus tan squared. And then we've got 3 tan theta. So rearranging on the left, tan squared theta minus 3 tan theta plus 1 equals 0. Now this one's not going to factorize, so I'm going to complete the square. Sorry, I'm going to use the formula. So my tan theta is going to be equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2 lots of a. So we've got 3 plus or minus, then we've got 9 minus 4, so the square root over 2. Okay, so I should get two values out. 69.1 is my first one, and 20.9 is my second one there. Now that's one for the positive and one for the negative coming out. Now I need to go to my cast rule or cast method to find the additional angles. So first time we've got 60.9 in here, as it was a positive value, positive tan, which means then we're also looking in this section where tan is positive, as I said, so 180 plus 60.9. So we got theta is 180 plus 60.9, so we're looking at 240.9 there. Now additionally we need to look at the other value that we have, my 20.9. Okay, so 20.9, it's also positive, so we're looking in the same two sections. So I'm just going to rub it out then, since we're looking in the same sections. My other value is 180 plus 20.9, so we're looking at 200.9 degrees. So give my answers to three significant figures. We get 20.9, 69.1, 201, and 241 degrees. Oh, my apologies. Really silly mistake there. Easy to do. It's not 60.9, it's 69.1. So we're looking at 249.1 for that one. So my angles are 249 is my final answer there. And it just goes to show that you should always just check back through your work just to make sure, because as soon as I checked back there, I realized I wrote, instead of writing 69.1 over here, I wrote 60.9. I've done it here. Okay, so that's 69.1. So it's really important that you do check through your work, because even having done these a long time, and when you're really good at them, you can still make a careless error. So part B, cot theta equals 1 minus cosec squared theta. Now remember, we want to change the squared term to match my non-squared term there. So cosec squared is 1 plus cot squared theta. So we've got cot theta equals 1 minus 1 minus cot squared theta. So 1 minus 1 is obviously 0, and I take the cot squared to my left side, so we get cot squared theta plus cot theta equals 0. Now it's quite important here again that we factorize, not divide through by cot. So cot theta equals cot theta plus 1 equals 0. So cot theta equals 0, or cot theta plus 1 equals 0, where cot theta equals -1. Now, cot theta equals 0 doesn't exist. If you made it tan, it'd be 1 over 0, which obviously doesn't exist. And then this one, tan theta, will be 1 over -1, so it stays as -1. So if I use my calculator, it will give me -45 degrees there, which obviously isn't in the range. Personally, I'd always use the positive value, which is 45 degrees, as this gives me this angle here and enables me to use cast quickly and efficiently. So tan is negative in this section and this section. So our values of theta are 180 minus 45 and 360 minus 45. So we're at 135 and 315 degrees. And we're done. In part C, again, we're changing the squared term. So tan squared would be sec squared minus 1. And this equals sec 2 theta minus 1. So sec squared 2 theta minus sec 2 theta equals 0. Factorize out sec 2 theta, and then sec 2 theta equals 0, and sec 2 theta minus 1 equals 0. So sec 2 theta equals 1. Now at this point, or I could have done it a bit earlier, would have been nicer, but I want to let x equal to 2 theta. Now I'll do this bit in black. So we've got sec x equals 0, or sec x equals 1. But I also need to deal with my range. So if we think about it, at the moment we've got theta is between 360 and 0. So 2 theta is between 720 and 0. So my range of x is between 720 and 0. Okay, so let's get my two values here. Obviously before that, sec x equals 0 cannot exist. 1 over cos, 1 over 0 doesn't work. So sec x equals 1, that one we can do. 1 over cos x equals 1, okay, or cos x equals 1 there. So x equals 0 degrees. Okay, now it's a matter now of going up to 720 degrees. And there is my final answer. Let's look at part A. So tan squared is sec squared x minus 1, which equals 2 sec k. Apologies, it's not an x we're dealing with, it's a k. So this is sec squared k minus 2 sec k minus 1 equals 0. So let's let y equal to sec k. Then we've got y squared minus 2y minus 1 equals 0. Let's complete the square. Y minus 1 squared minus 1 minus 1 equals 0. So we got y minus 1 squared equals 2. y minus 1 equals plus or minus 2, y equals 1 plus or minus 2. And since y is sec k, so sec k equals 1 plus or minus plus or minus root 2 there, the root's in. And then I would say that sec k is equal to 1 plus root 2 because 1 minus root 2 is negative. And I suppose if you look back at the original tan squared, this has to be a positive number. 2 times this would have to be a positive number, the sec k, so we're going to use the positive. Okay, part B. So 1 over cos k equals 1 plus root 2. Cos k will equal 1 over 1 plus root 2. And then we need to rationalize the bottom of this, so multiplying by 1 minus root 2. So we do 1 minus root 2 on the top, 1 minus 2 on the bottom. So that means that cos k equals 1 minus root 2 over negative 1. Therefore, it will be positive root 2, negative 1. And there we have shown or deduced that cos x equals root 2 minus 1. Okay, part C solving. So tan squared k equals 2 sec k. Tan squared could be replaced by sec squared k minus 1. And if you're not careful, you could go through working all this out from scratch in part C. But if you remember, this is what we did in part A to get to the sec. And then from A to get to B, we converted it. So all we need to do is simply start with B. Cos k equals root 2 minus 1. Okay, and solve that for k. And that gives me 65.5 degrees using my cast method. 65.5. And cos is positive, obviously here and here. So my second answer is 360 minus that. So our answers are 65.5 degrees and 294.5 degrees there. And we're done with that question. Okay, part A. So if we start with x equals sec theta plus tan theta, 1 over x will be 1 over sec theta plus tan theta. And then I want sec theta minus tan theta. So let's multiply top and bottom by that. Sec theta minus tan theta. Okay, that would then give me on the top sec theta minus tan theta, and on the bottom I would have sec squared theta minus tan squared theta. Now rearranging 1 plus tan squared theta equals sec squared theta, I can see that sec squared minus tan squared is going to be equal to 1. So this is equal to 1. So therefore this is equal to sec theta minus tan theta. And that's part A done. So part B, x squared, so we're looking at sec theta plus tan theta squared, 1 over x squared, so this is going to be sec theta minus tan theta squared plus 2. So we've got sec squared theta plus 2 sec theta tan theta plus tan squared theta for my first bracket. Then I've got sec squared theta minus 2 sec theta tan theta plus tan squared theta plus 2. Just move that over a little bit. So looking at what I've got 2 sec squared theta. My 2 sec tan will cancel my negative 2 sec tan. I've got 2 tan squared theta plus 2. Now 2 sec squared theta plus, take 2 out here, and I get tan squared theta plus 1. Tan squared theta plus 1 is sec squared, so that's 2 sec squared theta plus 2 sec squared theta, so we got 4 sec squared theta. And that's the best way. Obviously we could have turned the sec squared into tan squared, which would have given us 4 tan squared plus 4, but that's probably not the simplest form. So let's start with 2 sec squared theta minus, now tan squared theta is sec squared theta minus 1. So we've got 2 sec squared theta minus sec squared theta plus 1 equals p. So we got sec squared theta equals p minus 1. So 1 over cos squared theta equals p minus 1. Cos squared theta equals 1 over p minus 1. Now cos squared is 1 minus sine squared. And if I rearrange, I get 1 minus 1 over p minus 1 equals that sine squared theta. Making this a single bracket, sorry, a single fraction. That's what I was doing. And then on the top we got p minus 2 over p minus 1 equals sine squared. And then we want cosec, so we're going to flip it again. So 1 over sine squared here would be p minus 1 over p minus 2. Therefore cosec squared theta is p minus 1 over p minus 2. And that is what I've done there. Okay, now alternatively, instead of at the start here when I changed the tan into sec, I could have changed the sec into tan and I would have got the same answer. Maybe it would have been a little bit quicker, I'm not sure. Hopefully you found this video useful. If you do, please like, subscribe, tell your friends about it. If I know a lot of people want these videos, then I will make sure I make them for all of the modules.